So again, f of x comma y, this is the function. Fx means the partial derivative. I cannot find a straight derivative. I cannot differentiate with respect to x and y at the same time. It's not possible. I can differentiate this function with respect to x to find fx, keeping y as a constant. So for this one, y is a constant. So 3x squared y, negative 6x. There is no x here, 0. Now let's find fy. I differentiate with respect to y. When I differentiate y, I get 1. When I differentiate this with respect to y, there is nothing. It's a constant. When I differentiate this with respect to y, I get positive 12y squared. So I determined the first partial derivatives for this function. Now I want to determine the rest, the other 4. So to find fxx, very easy. I differentiate this with respect to x. So 3x squared prime is 6x. Of course, times y. I differentiate negative 6x with respect to x, I get negative 6. Now I want to differentiate fyy. When I differentiate this function with respect to y, there is no y here, 0. When I differentiate this with respect to y, I get 24y. So I determined 2 second order or second partial derivatives. Now I want to find fxy, meaning I differentiate this fx with respect to y. When I differentiate this with respect to y, I get 3x squared. There is no y here, it's 0. Now fyx has to be the same. That's a control. If it's not the same, go ahead.
Can you move the paper down a little bit so I can see the original? Yes, a little bit. Yes, I can see it.
So can you write it, because I am recording and I'm making sure that both can see it, both cameras. So now fyx, when I differentiate this with respect to x, I get 3x squared. This with respect to x is nothing. If these two are not the same, then I'll say oops and go back to the drawing board. These derivatives will help us find max-min. Before we go to the last item of the class, which is max-min for these functions, I would like us to choose other, at least 1 more, 2 more, till we get to the max-min. So, page number. I need page number 6.2. Page number is 566. So please choose any function you want so we can find all derivatives, all 6 derivatives, fx, fy, fxx, fyy, fxy, fyx. Find the 4 second order partial derivatives. I will not be able to find the second order partial derivatives if I don't find the first. I can jump to the second, as we know. So we can choose an example from here or an example from here. Let's choose. Anyone would like to choose, or I will? Okay, I will. So let's say 30. So f of x comma y is x to the 5th, y to the 4th, plus x to the 3rd, y squared. Anyone would like to help here? Please. It's okay if you're wrong. It's always okay if you're wrong. We're studying. Can anyone give us fx for this function? Anyone?
5x to the fourth.
Very good. Times y to the fourth plus
That's 3x squared.
y squared. Excellent. So Fy. Can anyone give us Fy? Anyone, please. Fy.
X to the fifth,
Yes. So 4,
or
x to the fifth, y to the,
hold on, I'm confused.
we're differentiating with respect to y. 4y to the third.
So why did X change?
It didn't. I copied x to the fifth.
Oh, I see. Okay, sorry.
No worries. Plus.
Okay. Mm-hmm.
Plus.
2
Yes. X to the
X
third.
to the third Y.
That's it. Awesome.
Okay.
Perfect. Now we want fxx. We're differentiating this again with respect to x.
$20x to the third.
Yes. Y to the fourth plus
6x.
y squared. Excellent.
Y squared.
Fyy. This again with respect to y. It's the same process. We're just differentiating y, not so
X to the fifth,
yes, y squared.
y squared.
Excellent. And we differentiate with respect to y, so we only have 2x cubed. Great job. Now we want fxy. fx, but now we are differentiating it with respect to y. x to the fourth, y to the third, plus 6 x squared y. Finally, fyx. It has to be the same with this. If it isn't, I'll say oops. So I covered it up so we are not influenced by it. So fy, but now we differentiate with respect to x. 20x to the fourth, y to the third, and then plus 6x squared y. If they're not the same, something is wrong. But they are. Okay. Finally, how do we find max min for these functions? And I just want the page number. Where is the page number? It's 576. 576. Okay. We want to choose a problem from 1 through 14. Find the relative max or min value. So I can explain how there is a procedure similar but not quite with a regular procedure for functions of one variable. I'm going to start with number 1, let's say, and then you choose the next one. And this is the last item of this class. And of course, we have a lot of reviewing to do. X squared plus xy plus y squared minus 5y. So in order to find max min for such a function, First, we have to find the 6 partial derivatives. So this is step number 1. So I have to find fx, I have to find fy, I have to find fxx, I have to find fyy, I have to find fxy, and I have to find fyx, just to make sure that they are the same. Much simpler than the previous example. Can anyone give us fx? Fx. What is it?
2x
Very good. Awesome.
y
Yes, plus y. That's it.
plus
That's it.
oh,
There is no
Oh,
x.
so
There
you
is no
don't say-
x. Done.
don't
Fy.
go away. Got it.
Yep.
Okay.
Fy.
Is it
Nothing.
nothing? Right? Because y is 1 now.
Yes, but there is x. 1 times x is x.
Oh, because x is left. Okay,
See,
plus
these they cannot be
y.
this. They cannot be the same. This one doesn't have y and it's 0, but this one has y. It cannot be 0. Plus.
Got you. Okay. 2y minus
Yep.
5.
Yes. Perfect. Fxx. Fxx.
Oh, you wanted me to keep going?
Anyone. 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 Can anyone differentiate 2x plus y with respect to x? Brian, are you with us?
Yeah, I'm here.
Yeah. So can anyone differentiate 2x plus y with respect to x?
Two.
Exactly. Excellent. Fyy. Fy with respect to y. Can anyone differentiate this with respect to y? Fyy, this function with respect to y. What do we get? I saw the text? No.
2.
Exactly 2. Excellent. Fxy. Fx with respect to y. Fx, but now with respect to y.
Zero.
When we differentiate y, we do not get 0.
Oh, is it 1?
Excellent. Finally, Fy with respect to x.
One.
Excellent. Good. So this was part 1, or step 1. Step 2. Solve the system of equations fx equals 0, fy equals 0. This is the same with the critical numbers from before, but 2 variables. Fx, 2x plus y equals 0. Fy, x plus 2y minus 5 equals 0. I have to solve this system. Okay. So from here, if I move 2x to the other side, I get y equals negative 2x. By substitution, I will replace y in the second equation by negative 2x. So I have x. 2 times negative 2x is negative 4x. I will put 5 to the other side. So x minus 3x, I meant to say x minus 4x is negative 3x equals 5, so x equals negative 5/3. I need to determine y. Well, I know that y equals negative 2 times this. So this will be 10/3. I have a point. The point, which is a critical number or a critical point, is negative 5/3, comma 10/3. Final step, step 3. The D test. Here's what the D test says. That's the final step, and we will identify whether this is a max, min, or none of the above. So what is the D? D is a number, and here's how we calculate it. Fxx evaluated at negative 5/3, 10/3, times Fyy also evaluated at negative 5/3, 10/3, minus Fxy also evaluated at negative 5/3, 10/3, because that's our discussion. This is the point we are talking about. But all of this has to be squared. And then I'll tell you what happens. Let's calculate D for this point. Fxx is 2. I don't even need to plug in anything, because Fxx for this function does not have anything to plug in. It's just 2. So this number is 2. The same thing with Fyy. There is no x and y to plug in. Negative 5/3 and 10/3 is also 2. So this is 2. Now, Fxy, again, is just 1. I don't have anything to plug in here. Otherwise, I would have had to plug in negative 5/3 and 10/3 and get a number. But there is nothing to plug in. It's just 1. So what is the final answer for D? 2 times 2 is 4. 4 minus 1 squared, which is 1. This is 3. So what are the options? And here's our conclusion. No other calculations are required. We're just going to discuss the D test, and they will tell us what this means. If D is positive and Fxx at this point, A comma B in general, is less than 0, A comma B is a relative max. Relative max. If D is positive and Fxx at this point is positive, A comma B will be a relative min. If D is less than 0, no max min. If D is 0, test not applicable. We call this a saddle point, but no max min. So now we have to draw a conclusion. We determined that D was positive, so we are here. D is not negative and D is not 0. So then I am checking Fxx. Because Fxx is a positive number, I will say this problem, or this function I better say, has a relative minimum. So Fxy, which was x squared plus xy plus y squared minus 5y, has a relative minimum at negative, what was it, negative 5/3, comma 10/3. Now, if we are asked to find what it is, then I have to plug it in. Relative min is f of negative 5/3, comma 10/3. So, this squared, 25 over 9. This product, minus 50 over 9, plus 100 over 9 minus 5 times y, 50 over 3. Okay, so this minus this plus this is 75 over 9 minus 50 over 3, so I have to multiply this by 3. 75 minus, oh no, 450 divided by 9. So what is it? Negative, correct me if I'm wrong, 375 over 9. So again, let's review the d-test and then work on another problem. Step number 1, immediately find all 6 partial derivatives. Step number 2, I only take fx and fy, set them equal to each other, set them equal to 0, and then solve the system. If I don't get any point, there is nothing to say. There is no max-min. If I get a point or more than 1 point, then I have to go through the d-test for both or more points. In this case, we only found 1 point, and we determined the d-test is fxx at this times fyy at this minus fxy squared at that point. We calculated this. We had 4 minus 1, which was 3. Because it was positive, it has a max or a min. When d is negative, no max min. When d is 0, the test is not applicable. So we found that d was positive. Furthermore, we found that fxx was a positive number. It's like a puzzle. Since we found that it's a positive number, we said, okay, that number, though that point, negative 5/3, 10/3, is a relative minimum. Because the d number is positive, and because fxx was positive as well. So now, what is the minimum, or the relative minimum, of course? I have to calculate it. Okay, so let's choose. It's a lot of calculations, but not difficult. So please choose another problem. I would like to illustrate with another problem. We can look at a word problem. Let's look at a word problem this time, a maximum profit. So I'm on page 9. Let's look at the maximum profit. And there is no more new material after this. This is it. So maximum profit, Humphrey's Medical Supply finds that its profit in millions of dollars is given by P of A, comma, N. So this is problem 21. Is negative 5a squared minus 3n squared plus 48a minus 4n plus 2an plus 290. A is the amount spent on advertising in millions. N is the number of items sold in thousands. Find the maximum value of P and the values of A and N where that happens. Okay. In step number 1, I have to find 6 partial derivatives. I have PA, I have PN, I have PAA, PNN, PAN, and PNA. That's my first step. Because I need to employ the test, the d-test, and all these are required for the d-test. And for the system. Eventually, the first 2 will create a system.